Hari Om. Now we are covering all the properties of Laplace transforms.
Now let's see what is this first shift property. This is very important property. Very simple. What it says is if a function is multiplying with e power at, if it's a function is multiplying with exponent term and you have to find its Laplace, it's very simple. So whatever you'll get answer, simply lastly you should substitute in place of s to s minus a. If a is positive, if here a is negative, you will shift s to s plus a. Okay, so see here, if Laplace of e power at f of t is f bar of, instead of s you will write s minus a. If it is e power minus at, instead of s you will write s plus a. That's it. Okay, sometimes they may ask in exams, so let me show you the proof of first shift property. Okay, nothing very simple. So by definition, what you know, Laplace of f of t is what by definition? 0 to infinity e power minus st f of t dt. I also told you this can be written as f bar of s. Okay, this is point 1. Next, Laplace of e power at f of t is what? Integral 0 to infinity e power minus st. Now what is my function? My function is this whole term, so I have to write this also. No. Okay, over. Now what will be this? What will this become? What is a power m into a power n? A power m plus n, right? So this will become e power minus t into s minus a. If I take out common t, f of t dt. So now see, if s is there, okay, with minus t, if s is there, what we wrote? F bar of s we wrote. So in with minus t, if s minus a is there, what we should we write according to 1? So you write by 1, we can write this as f bar of s minus a, because here s is there. Okay, because we wrote s, here s minus a is there. By this definition we can write it as f bar of s minus a, hence proved. See, Laplace of e power at f of t is f of bar of s minus a. This is only now first shift property, hence proved. Okay, so quickly we'll solve this. Laplace of e power 2t into sin t. By first shift property, we have exponent term multiplying with our function t. So just think it's not there. Okay, this is not there. Then what is your answer? Laplace of sin t answer is 1 by s plus 1. Am I right? Now because it is there, what is a 2? So I'll write here, sorry, this is s square, no? S square plus. So in place of s, I'll write s minus 2. That's it. Understood? Same here. If this is not there, what will be your answer? So you should consider this like this. Laplace of e power minus 3t into, what is sin square t? I already told you, 1 minus cos 2t by 2. Okay. So now Laplace of, multiply with this, e power minus 3t into 1 by 2 minus e power minus 3t cos 2t by 2, isn't it? So now Laplace of, put this constant outside, 1 by 2 Laplace of e power minus 3t minus 1 by 2 outside, Laplace of e power minus 3t cos 2t. Okay, now you see, think it's not there. Okay, 1 by 2, what is this answer? 1 by s plus 3, isn't it? Minus 3 plus 3. Next, minus 1 by 2. If it's not there, what is your answer? Your answer is s by s square plus 2 square. This is your answer, right? So directly you can write here s plus 3, you can write, or you can write it like this and write here, bracket down, you should write like this, s2 s plus 3. So in next step you can write same, you'll write like this. Okay, so either you can write like this, or in the step only you can write direct. You should write by first shift property. Okay. So I'll show you another way to solve these questions. So they asked you this. So you say consider what you know this one. Okay, consider Laplace of t plus 3 whole square. Consider this. What is the answer? T square 9 plus 60. What is the answer? For t square it will be 2 factorial by s power 2 plus 1 plus for 9 into Laplace of 1 is 1 by s plus 6 into Laplace of t means t power 1 means 1 factorial by s power 1 plus 1. So this is your answer for this. So now Laplace of t plus 3 whole square into e power t. By first shift property, you'll write, and you can write wherever s is there, what you should write? Here it is 1 into t, no? So here a is 1. So what you should write? Shift s to s minus 1 over answer. Wherever s is there, you put s minus 1. Okay. So next question. E power minus 3t 2 cos phi t minus 3 sin phi t. So this also will solve. Very easy. First, if you want to consider this, you'll write, okay, Laplace of only this thing you'll write here, which is 2 outside. Cos phi t answer is s by s square plus phi square. Here minus 3 into phi by s square plus phi square over. Then you'll write Laplace of this whole thing you write. This will be, now here a is my minus 3. So I should shift s to s plus 3 over. Your answer is over. So now you understand why Laplace is very easy. Okay. So it's over. Say further. Okay. Sorry, this is here. Okay. This is 2 into, this is minus 3 into this. Okay. So first you should write by linear property we did. Next by first shift property. Okay. By linear property this. By first shift property this. So see this. The moment you say exponent term, you should get in your mind first shift property. So this, how will you find? Product is there. So we should convert to this formulas. Sin A cos B. So Laplace of, you should write consider Laplace of sin 2t cos t, which is sin of A plus B. 2t plus t 3t plus sin of A minus B is t. So Laplace of, by linear property, write it by linear property. Okay. Now what is the answer? 3 by s square plus 3 square 1 by s square plus 1 square. So this is your f bar of s. Okay. Now this is my f of t. So this is e power at f of t, which is my answer is f bar of s minus a, which is s minus 4 I should write, no. So therefore Laplace of is equal to f bar of s minus 4. That is, in place of s put s minus 4 over. That's simple. Okay, further simplify this. I think we forgot something. Yeah. So this is 1 by 2, no? 1 by 2 times, right? Here we have 2. Sorry, very sorry. I should write here 1 by 2. So don't forget 1 by 2. So 1 by 2 times What is this? S square minus 8s plus, this is 16 plus 9, 25. S square plus 16 plus 1 is 17. Okay, over. This is your final answer. So this is another interesting question. See, did we have exponential term here? No. But if you can see, what is cos HAT formula? E power 80 plus e power minus 80 by 2. Isn't it? So we have exponent terms. Okay. Into sine bt. Instead of writing here by 2, I am writing here 1 by 2 outside. Okay. So 1 by 2 Laplace of, by which property? By linear property. We are dividing it like this. This 1 by 2 is for whole thing. So this is by linear property. Next by first shift property. What is Laplace of sine bt? B by s square plus b square. But because here e power 8 exponent term is there, we have to shift s to s minus a, right? That's it. In same way, what is formula for same? No, b by s square plus b square. But because here minus a is there, we have to shift s to s plus a. S plus a whole square. Okay, over.
So in this question, they asked to show that Laplace of t sine at is 2as by s square plus a square whole square. So this can be done in many ways. So if they ask you, or if you want to do it by first shift property, then here we don't have e power anything, right? We don't have exponent term. So we have to create exponent term here. Other way we can do it very easily by multiply by t property, which we'll be discussing in very soon. So that with that we will get in one two steps. That is easy. But if you want to prove it, or if they ask you to prove it by first shift property, you should do it like this. So we know that e power it is cos theta plus I sin theta. Yeah, we know this. So in place of theta, if I can take 80, then what it will become? E power I 80 is cos 80 plus I sin 80, right? So here, what is this sin 80? This is called imaginary part. This is called cos 80 is called real part. Okay, so sin 80 is called imaginary part. So instead of this imaginary part of e power I 80, so I will write my question like this: Laplace of t into imaginary part of e power I a t. I'll take this outside. Imaginary part of, okay, Laplace of t into e power I a t. So because here exponent term is there, you'll normally do it like your first shift property. What you will do, think it's not there. What is Laplace of t? It is 1 by s square. But here I have to shift. What is there? See, before we used to have e power at, and we used to shift s to s minus a, means this part. Okay, we are shifting. So now what is there? Ia is there. Instead of a, ia is there. So what should I write? S minus ia. Instead of s minus I should write s minus ia. Okay, whole square. Y square. What is Laplace of t? Laplace of t is 1 by s square. So I am shifting my s to s minus ia. Okay. Now this I have to write it like this. Imaginary part of. Can I get imaginary part of this like this? No. I should have something like a plus ib. Then I can tell this is imaginary part, this is real part. So to get that, I should do rationalize. Then I'll get this to numerator properly. So I'm rationalizing this with s plus ia whole square. Now you find out what will. So this is s square plus 2ias minus a square by a plus b into a minus b is a square minus b square. But here squares are there, so we should put square also. Okay.
Next we'll get s square minus a square. This is minus I square is minus 1, so it will become plus. And I into 2as. This part will write different. So now see, compare this with a plus ib. So what is b? That is imaginary part. This. So we should write imaginary part of this, no? So imaginary part of this is this one. So what you'll write final answer? Hence proved. Okay, see. So the Laplace of this, which is nothing but imaginary part of this, which is nothing but this. So this is how it got proved. In same way, what is Laplace of t cos at? Very simple. This we should consider real part. That is this. So Laplace of t cos at is s square minus a square by s square plus a square. This is real part. In the same way, we'll proceed for this question also in the same way, but instead of imaginary part, we'll write here RP, real part, and we'll get this. Okay. So next is change of scale property. It's very simple. So if any constant is multiplied to inside the function, okay, then we can write it 1 by a f bar of s by a. So if a Laplace of any function is f bar of s, then if it's multiplied by if it is multiplied with a, we write like this. If it is divided by a, we write it like this. Okay, ulta. We'll see one question for better understanding. So see this question. If Laplace of this function is this, okay, then we have to prove Laplace of the function multiplied with 3. Okay, see t is multiplied with 3 here. Okay. So first we will see that given that Laplace of f of t is 1 by s e power minus 1 by s, which is nothing but f bar of s, right? Laplace of f of t is f bar of s, which is nothing but this. So now what we know by change of scale property, if a Laplace of this is f bar of s, then Laplace of f of at. So now we have to find f of 3t, right? See. So according to change of scale property, Laplace of f of 3t is what? F bar of 1 by 3 f bar of s by 3, because my a is 3. So see, Laplace of f, this is 1 by a f bar of s by a, right? So I am writing 1 by 3 f bar of s by 3. So what is f bar of s by 3? I know this. It is nothing but substitute in place of s by 3. You'll get it. So 1 by, in place of s by 3, e power minus 1 by, in place of s by 3. That's it. So this is my Laplace of this, because remember this is also there, we should not forget that. So this is 1 by 3 into 3 by s into e power, can I do this ulta, minus 3 by s. So this is my Laplace of f of 3t. So what is now Laplace of e power minus 3 f of 3t? So I already told you, this is the first shift property, right? If any function is multiplied with exponent term, okay, then what will we do? We will shift the s. So now this is my f bar of s. Before this, now this. So now how should I shift? I should shift s to f bar of s plus 1, right? Because here minus 1 is there. A is minus 1. So which is nothing but put in place of s plus 1 over. You got your answer. 1 by 3 into 3 by s plus 1 e power minus 3 by s plus 1, which is nothing but e power minus 3 by s plus 1 by s plus 1. This you have to prove. You proved it. Okay. So first we used which property? Change of scale property. Then we used first shift property. Okay. So write these in your formula sheet. We have learned first shift property. Then we have learned change of scale property also now. So next we are going to multiply by t property.
This you can remember later or write later. This is will be using in application, not now. Okay, so this is very important for the last topic. There anyway we are going to study this. Now focus on this. Multiply by t property. So don't get confused with this and this. In chain of scale property, t, so any constant is multiplied inside, but here t itself is multiplying outside. Okay, for example, Laplace of t sine t. Okay, so t is multiplying with a function, so then we will use this property. So what it states, nothing, just you need to put the derivative for f bar of s. Okay, you should put a derivative and also minus symbol if n is odd, if n is even, no need. Okay, so t square, t cube, it is applicable for all these things. Let's see some questions. Here Laplace of t sine t. The moment you see t is multiplying, you should get in your mind it is multiply by t property. Okay, so first what you should do, this is my f of t, right? So do you know that answer? Yes, you know the answer of Laplace of sine t. What is it? It is 1 by s square plus 1 square, right? So you know this. Now it is multiplying with t. So this is your f bar of s. So now what you should do? Derivative of, you should do derivative of f bar of s, which is nothing but derivative of 1 by s square plus 1. If you do this, if you get the answer, that's the final answer. So what is derivative of 1 by x? Minus 1 by x square, right? So this we can write minus get cancelled, 1 by s square plus 1 whole square. You should also do inner derivative. Inner derivative for this s square is 2s, 1 is 0. So this is your answer. This is very important question. Clearly you can see that it is multiplied by t. Okay, so now write Laplace of cos h 3t. You know this answer, no? S by s square minus 3 square, which is 9. Okay, now you have to find Laplace of t cos h 3t. Then you will find Laplace of t square. So slowly you can go stepwise, or else you can directly go with t square. Now we'll take minus d by ds of s by s square minus 9. If you take here square, you should take here minus 1 whole square, d square ds square, which is nothing but second derivative. You will be doing anything, you'll get the same answer. So let's continue. So this is, you should use u by v, right? U by, what is u by v? In denominator v square, here uv dash minus vu dash. First you should do for numerator derivative. So I'm putting minus like that only. S square minus 9 whole square. For s it is 1. 1 into s square minus 9 minus, for this derivative, s square derivative is 2s into s into numerator, so square. So now we are getting minus 2s square plus s square minus s square. Here you already have minus, so s square and minus minus plus. Okay, s square minus 9 whole square. So first this is my f bar of s, then I apply derivative. Now this will be my f bar of s. Now again I have to apply derivative. Again t square cos h 3t, or you can write it as like this, t into t. So for this no, so we have to apply derivative on this. Okay, t into t. Okay, so now minus, again minus derivative of s square plus 9 by s square minus 9 whole square. If you find this, the final answer will be coming. So now see, I'm putting minus like that only. So now this whole square is there. First we'll write s square minus 9 whole power 4. Okay, next numerator derivative, s square derivative is 2s into denominator, which is s square minus 9 whole square. Minus is there. Next minus of, what is the denominator derivative?
first this is like x square, you will get 2x, no? So first you should write 2 into s square minus 9. Then you should do inner derivative. What is inner derivative? 2s minus 0. And you should not forget to multiply with numerator. vu dash. So now this if you find, so see, I'm writing here. So 2s cube, first we will take x square minus 9 common, okay? S square minus 9 common. Minus is there, okay? I'm putting here minus. S square minus 9 whole power 4 cancels and it becomes 3. Inside C, here 2s into 1 more is there. So 2s into s square minus 9 minus. So here we are taking this if you assume. Yeah. Then 2 to the 4s into s square plus 9. If you solve this, you will get 2s cube minus 18s minus 4s cube minus 36s by s square minus 9 whole cube, and minus is there. So final answer will be minus 4s cube plus 2 minus 2 minus, so 2s cube minus minus plus 36 plus 18 54 minus minus minus, oh you'll get plus. So this is your final answer. This is very correct. I checked in many channels and many websites. So I'll tell you what will happen if you take like directly in place of this. If you took Laplace of t square, then what you should write? Minus will won't be there, no. D square ds square s by s square minus 9. So first you will find the derivative. Then first, so you will tell consider derivative of s by s square minus 9, which is s square minus 9 by s square minus 9 whole square. You'll get like this. Okay. And this is only one derivative. Again you have to find derivative now. So you should take again derivative. If I put this minus outside, you can see this step and this step is same. Here if I multiply minus s square minus 9. So eventually you will come to the same answer. You proceed any way you like. It's also important question. So we'll go stepwise. First, what you know, Laplace of sin t, which is very easy, 1 by s square plus 1. Next, consider Laplace of t sin t, because this if we take last, it will be easy. Laplace of t sin t, which is minus derivative of 1 by s square plus 1, because this is my f bar of s. Now this will be s square plus 1 whole square, u by v I am applying, I'll get minus 2s. Minus is also there, no? So it will become 2s by s square plus 1 whole square. Now finally e power t sin t. This will be, simply I have to shift this. If this is my f bar of s, I have to write f bar of, here 1 is there, so minus 1, which is nothing but 2 into s minus 1 by s minus 1 whole square plus 1 square. Nothing, I just kept in place of s minus 1 over. So simplify further, okay? You'll get this final answer. These type of questions are important, where you have to go stepwise. Exam, write by multiply by t property, by first shift property. So like that you have to write and complete the answer. So same model, but somewhat difficult because t square is given. So first we'll proceed with cos t. Next we'll take t square. Lastly we'll take this because we have just need to substitute s plus 2. Okay. So first Laplace of cos t. What is Laplace of cos t? S by s square plus 1. Next Laplace of t square cos t.
So directly if you want you can take plus d by ds of s by s square plus 1, which is d by ds of s by s square plus 1. So what is this? S square plus 1 whole square. This is 1. So s square plus 1 into 1 minus, for this 2s s. So which you will be getting 1 minus s square by s square plus 1 whole square. So now if you have to find derivative of this, which you will be getting s square plus 1 whole power 4 on top minus 2s into s square plus 1 whole square minus, what is this, 2 into this bracket, next inner derivative, 2 into s square plus 1, inner derivative of this is 2s plus 0, into numerator also we should multiply, don't forget, common. So minus 2s into s square plus 1, and here minus 2 into 2 4s into 1 minus s square by s square plus 1 whole power 4 is cancelled. Now here minus 2s cube minus 2s minus 4s plus 4s cube by s square plus 1 whole cube, which is 4s cube minus 2. So 2s cube. Here minus 6s by s square plus 1 whole cube. Okay. So what is this? This is Laplace of t square cos t. Okay. If you're asked Laplace of this, you should get this answer. But we are not asked that. We are asked Laplace of t square cos t into e power minus 2 t is also there in our question. So I have to shift my s to s plus 2. So if you shift, your answer is completed. If you don't shift, you lose mark here. If you want, you can simplify, or else you can leave it. The last two properties. The first one is divide by t. I'm showing you these two at a time because most people get confused between these two in exams. So divide by t property means, like in multiply by t, t is multiplied with f of t. Here t is divided with f of t. Okay, be clear. And here it is not. Here we did derivative. Here we are doing integration. That's it. Here we kept minus. Here we limits are s to infinity to remember. Okay. So now what is this? Laplace transform of integrals means, if anytime you see integral and there they apply Laplace transform on that integral, if they apply, then we'll consider this property. The answer is simply 1 by s f bar of s. So in all these, what I didn't write the first line. In all this, the first line is this: if Laplace of f of t is f bar of s. Okay. So f bar of s is nothing but Laplace of f of t. No need to write, so I didn't write. You know, no? Okay. So you understood now when to apply this and this. I'll show you some examples also. So small examples I'll show, big examples we'll do at a time. Okay. See Laplace of sine t by t. Do you know Laplace of sine t? Yes. That is not even 1 by s square plus 1. Now Laplace of sine t by t is integral s to infinity this thing. Okay. S to infinity. Now you can do integration. This is also, you will apply integration formulas, applying limits, then you will get the answer I got here, cot inverse of s. So these are simple problems in which examiners don't ask. So we'll practice the questions that come for exam. In the same way, see this Laplace of sine square t by d. First you'll write Laplace of sine square, which is you'll convert. We already did all these sums before, no? So I'm not doing again. So you'll get the answer 1 by 2 into this something. This is your f bar of s. Now Laplace of sine square t by t by division property. This is
s to infinity, constant putting outside, 1 by s minus s is by s square plus 4 ds. With respect to s, no, everything. So now 1 by s, sorry, 1 by 2, what is integral of 1 by s? Log s, right? What is this integral? S by s square plus 4. So if you remember one formula, which is very very important, integration of f dash of x by f of x, this is log mod f of x. Okay, this is very important formula. So now if you multiply 2 and divide 2, you can see that s square plus 4 derivative is 2s, so this is satisfying. So let's write minus 1 by 2 log f of x s square plus 4. No need to write mod because this is positive function. So now my limits are from s to infinity. So you should be very careful while applying these limits. Okay. What you should remember very well in this question is log infinity is undefined. So we don't want to write undefined in our answer. So we'll do it in this way. First, let's say 1 by 2 common. So I'll get 2 log s minus log of s square plus 4. I'm not applying directly infinity here, okay? Which is 1 by 4 log, I am taking this 2 up, okay? Log of s square by s square plus 4, which is, now we will be applying limits for this, which will be 1 by 4 log, here also I can take x square s square common. Then what I'll get? Log, I'll write here 1 by 4 log 1 by 1 plus 4 by s square. I took x square common and cancelled. So now we'll apply limits. First we'll put infinity. So what is infinity? 4 by infinity is 0. So I'll get log 1. Log 1 is 0. So first my answer will be 0. Then lower limit. I should put s in which place? In s place only. Okay. So 1 by 1 plus, which is nothing but same. So write the same. 1 by 1 plus 4 by s square. So now minus is there. That means I can reverse this. So this is normally minus 1 by 4 log s square by s square plus 4. So if you want, you can take this minus inside and do it reciprocal. You will get 1 by 4 log s square plus 4 by s square. So now another question. First we will find Laplace of e power 3t minus e power 2t. Then we'll do by division property. Okay, first we'll do this. So now what is the answer? Do you remember the linear property? This we can divide it like this, no? So now what is the answer for this? 1 by s minus 3. Here 1 by s minus 2. This is my f bar of s. So now I have to write Laplace of e power 3t minus e power 2t by t. So what will this be? Integral s to infinity f bar of s. What is my f bar of s? This term. ds. So now see, what is integration of 1 by s minus 3? Log, right? Log s minus 3. Log s minus 3 minus log s minus 2. Directly I am writing like this. Log a minus log b is log a by b. So now we'll apply limits s to infinity. So again, if I apply infinity, I'll get log infinity, which I don't want because log infinity is undefined. So we'll take s common and cancel. So I'll get here, if I take s common, 1 minus 3 by s, 1 minus 2 by s. So now apply infinity. So what I'll get? Log 1 minus, this will be infinity, 3 by infinity will be 0. I'll get log 1 here also. So finally I'll get log 1 minus log of, put same, wherever s is there put s. So I'll get log of 1 minus 3 by s by 1 minus 2 by s. Okay. Log 1 is 0 minus log of, if you want multiply with s again, I'll get s minus 3 by s minus 2. Because minus is there, I'm just reciprocaling the numerator with denominator. So this is your final answer. So if you see a pattern is there in all these questions, that is where you'll start this, no? Whenever you see this type of questions, if this is there, s minus 2, s minus 2, the answer will be reverse. Previous question also, I'm not telling about constants, but just for your checking, s square by this will be there. In finally we'll get opposite, see, in final answer. Question also, we can see it is a clearly divide by t property, no? So first we'll find for this. So if you remember, while learning basics, we have learned some 4 formulas. I'll show you these 4. So also note these 2 formulas from the previous questions. Okay, I'll tell this formula we'll be using in now this question. So which formula we have to use now? 2 sin a cos b formula, sin a plus b plus sin a minus b. So 1 by 2 Laplace of sin a plus b 4t plus a minus b sin 2t. Okay, why? Because only now we can use linear property. Before we cannot use linear property for multiplications. Okay, so what is Laplace of sin 4t? This is 4 by s square plus 4 square, and this is 2 by s square plus 2 square. So now this is my f bar of s. Now I have to find this. So Laplace of sin 3t cos t by t is integral s to infinity f bar of s, which is this. So I'm putting constant outside and writing this inside. So with respect to s we are doing so ds. So now the formula I told you should write this one. 1 by x square plus a square formula is 1 by a tan inverse of x by a. Okay, so here we have integral 1 4 by s square plus 4 square. So consider it as 1. Okay, so now if you see properly, we can write 4 put outside. For this answer is 1 by a, which is 1 by 4 tan inverse of s by 4. In the same way, 2 outside, 1 by 2 tan inverse of s by 2. Okay, so now what are the limits s to infinity? So again trigonometric. So what is tan inverse of infinity? Tan is infinity at pi by 2, right? So now we have to apply it. Tan inverse of infinity is pi by 2. Next, I think we'll get 2 tan inverse. See, yeah, 2 into this and this now, minus lower limit, which is same. Just write it, tan inverse of s by 4 minus tan inverse of s by 2. So this is your final answer. If you want, you can I don't know, we can't further solve it. So this is your final answer. Okay, so next is Laplace of this integral. What is my f of t? My f of t is this whole function. F of t here is e power minus t cos t. As I told, once we'll again recall, by Laplace transform of integrals. What is that? Laplace of 0 to t
f of t dt, right? 1 by s f bar of s. So now compare. What is my f of t? Clear? Now we'll take Laplace of f of t. So I have to find f bar of s, no? How will I get f bar of s? F bar of s is nothing but Laplace of f of t. Laplace of f of t. First let's find it. So Laplace of my f of t is this. So this you know very well. Until now we have solved many questions on this. Simply it is s by s square plus a square, but we have to shift s to s plus 1, remember, which is s plus 1 by s plus 1 whole square plus a square. Sorry, this is 1, no? Okay. So if you see, this will be my f bar of s. So now, therefore, you will write this line. So Laplace of, okay, I am directly writing question. E power minus t cos t dt is equal to 1 by s into f bar of s, which is this. Okay, 1 by s into f bar of s is this. S plus 2 plus 2s, solving this. So this is your answer. Is it difficult? Not at all, no? So first we'll take this. We'll find Laplace for this. Then we'll substitute s minus 2. That is clear, no? Okay. So first to find this, we need to know sin t by t, right? See, this is very good question. You can expect this in your exam. First, stepwise we'll solve. First, what is Laplace of sin t? 1 by s square plus 1 tk. What is Laplace of sin t by t? Which property? Divide by t property. So limits are h to infinity f bar of s, which is 1 by s square plus 1. So this will be my tan inverse of s. Limits are infinity to s. So my answer will be tan inverse of infinity minus tan inverse of s, which is pi by 2 minus tan inverse of s. If you want, you can leave it here, or you can write cot inverse of this. So now this is done. Now this part. Laplace of e power minus t sin t by t. I should shift here, minus 1 is there. I should shift it to plus 1. So this will be my cot inverse of s plus 1. Am I right? Done. 3 steps done. Next, if you want, you can write like this. This is my f bar of s. This will be f bar of s plus 1, which is this. Okay. What is the next step? Laplace of 0 to t or infinity? Okay, this is 0 to t. 0 to t, this thing. Which property? Integral by t property. Okay. What is the formula? 1 by s f bar of s. Okay. What is Laplace of this 1 by s f bar of s? What is your f bar of s? This one. See, f bar of s keeps changing. The final output, this is my output final f bar of s. This is my output answer f bar of s. This is my output answer. This is my f bar of s. This keeps changing. So 1 by s f bar of s, which is nothing but 1 by s cot inverse of s plus 1 over. Finally, okay, finally, what is the, if I'm just remembering you, it's very easy. You just need to shift s to s minus 2. It's over. So what is the property? Shifting property. First shifting property. What is the property tells? If Laplace of a function is f bar of s, then Laplace of that function multiplied with f of t.
will be f bar of s minus a. This is your first shift property. So see this is my f of t, this is my f bar of s. Okay, this is my f bar of s. Then what will be this answer? That is nothing but my question. This will be f bar of s minus a. So I should do minus 2. The final answer is 1 by s minus 2 cot inverse of s minus 2, which is s minus 1. Okay, this is my final answer. So finally you can write Laplace of whatever there, or that whole question you write, this whole thing will be a power of s minus 2. Then write this step. Okay, how do you think we are going to solve this? We are not given find Laplace. Please understand that we are not given Laplace of this. We are told to evaluate using Laplace transforms. That means by definition. So this is very important model. By definition, what you know is very basic, very first line we wrote in this chapter. Laplace of a function is integral 0 to infinity e power minus st f of t dt, which is my f bar of s. This is the first line I told you in this chapter. So if you think how should I remember that this question should be solved by definition? See the limits. Limits are 0 to infinity, which can be only seen in the definition. Okay, that is the trick. And next thing, so now here my s is 2. Do you agree? This is e power minus 2t. So s is 2. What is my f of t? T cos t. That is the remaining left one, right? So t cos t. So if my answer here is f bar of s, so what do you think my answer here will be? My answer here will be f bar of 2, right? So first I have to find f bar of s, and if I substitute 2 in it, my answer is done. Do you understand the logic? Okay, so here first we'll write f of t is t cos t. Laplace of f of t is Laplace of t cos t, which you already know by now, multiply by t property. Okay, which is this I'm doing it fast because I already told you. Okay, now this is done. This what it will be this f bar of s. Now my answer is f bar of 2 over, therefore you'll write this write the definition. So using that, here s is 2, all that you write. Then finally my answer will be 2 square minus 1 by 2 square plus 1 whole square, which is 3 by 5 square, 25. So this question is very easy. You just need to understand the question. Evaluate using means you have to do it by definition. How to remember means limits. Okay, remember the limits. Now the very important note point I want to tell you all is compare the 3 questions. In exams, definitely you will get stuck. If you have any one of the question, especially these two, you'll get stuck which property to apply. So I'm giving you clarity. This is integral property because Laplace is applied on integration. This is not that property. Here Laplace of something is not given. They told evaluate using Laplace. That means we have to go by definition. And this third question, third variety. See, they're giving complex sums like this. E power 2t is also there and this thing is also there. So one thing is for sure, no? 0 to t is there and integration, Laplace is applied on integration, means which property is this? This only, no? Which is nothing but integral property. Okay? And the thing is s to infinity there.
Where do you see h to infinity? In divide by t property. So this will not be in our LHS. This is in our RHS. So here limits are s to infinity. So I want to tell you that don't get confused to limits. That's why I want to tell you this note point. Okay. Remember where you will get s to infinity divide by t. 0 to t you will get in integral property. 0 to infinity in definition. Be clear with these three limits. Okay. Don't get confused in examinations. Be very confident here itself.